Hi, I'm Davi, and thank you so much for clicking on today's video. If you are new, I am a 4th year computer science student with a minor in cognitive science, and currently I'm about to start applying for full-time positions. And so this will be the second video of this series. If you haven't watched the first one, I would highly recommend it. But I'm just going to be going through LeetCode problems and studying them for myself, but also explaining my entire thought process with y'all. Someone on my past video commented that they also solved the question with me, which I think is really cool. So if you would like to do that as well, I'd highly recommend it, because you can just pause the video, solve it yourself, brainstorm it or however you want, and then you can unpause it and see how I solved it. So we can all be here and thrive together. If you would like, my Discord will be linked down below, and you can come and ask me any questions that you would like. So without further ado, let's get into it really. So I have not done a lot of LeetCode, but a viewer in my Twitch chat, shout out to Diamond, yeah, you're being here, suggested that we do one easy and one medium. So if you haven't been on LeetCode, this is just the main page, and just wanted to show the main page, but these were the two questions that I picked out. I haven't read them yet, but I think we're gonna start with the easy question first and then move on to the harder question. So the first question here is called a number of good pairs. So given an array of integer nums, a pair ij is called good if nums equals nums at j and I is less than j. Return the good pairs. The good pairs are 0, 3, 0, 4, 3, 4, and 2, 5. Okay, so you're kind of just matching the pairs, but in subsequential order. And then 1, 1, 1 is just their all. So, okay. Okay, so we finished, and it was pretty good. I thought it was a cool question, intellectually. So, what did you think about it? So I have a nested for loop, and essentially so first I got a counter, because you're just returning the counter. You're only returning the number of occurrences that are true. So that's just truly the only thing that you need to keep count of. So this first loop for I is going from the beginning of the array to the end. So just from 0 to the end. The second nested for loop is going from I plus 1, so the number right before I, to the end of the array. And so then in the if statement inside of the nested loop, I check if nums at I equals nums at j, then you increase the counter. And so the reason that you don't have to check if I is less than j is because I hard-coded it and set it for j to always be 1 above it. So you're never checking the same number, and you're never checking 1 behind it, because j is always I plus 1. So that's why it's always in front of it. And so therefore that I plus I is less than j is kind of unnecessary to put inside of the if statement, but you can if you want. It would just be redundant, because inherently it would never be like that. But if you just logically go through the loop, the first time I will be 1, and when you go into the second loop, it's now 2. J is 2. So as you're going through this second loop, I'm checking 1 with 2. That doesn't work, so then you increase j again. 1 with 3, increase j. 1 with 1. That is true, so now counter becomes 1. Then you increase j again and do 1 match with 1, this one again, and that is true, so now counter is now 2. And then you check with 1 and 3. And when you exit that loop, I increases, and so now you're checking 2 with the rest of the loop. Then you go 3 with the rest of the loop, and then 1 with the rest of the loop, and then just like that. So that's just pretty much the problem. It's pretty cool. Let's submit it and see how that went. 4 milliseconds. Yeah, no, not very efficient. But that's okay. We're big chillin' either way. Okay, cool. So we solved the first question, and now to the second one. So the first question was under the easy category. So I just now decided to test myself a little bit and check on the medium. So you are given 2 non-empty linked lists representing 2 non-negative integers. The most significant digit comes first, and each of their nodes contains a single digit. Add the 2 numbers and return it as a linked list. I actually really like linked lists because you can dynamically allocate space, so that's really fun. But I also haven't done that in a really long time, so syntax wise it's gonna be a bit of a struggle, but it's okay. So we have 7, 2, 4, and 3, and then 5, 6, 4. So you're just adding these two numbers together and then returning them separately. Okay. They want the commas? So this question was actually much harder than I thought it would be. Actually getting into it. I'm not gonna lie to y'all. It took me a solid 2 hours. And even in those 2 hours, I still can't do it because of my runtime, but I can solve, like, my algorithm does solve for smaller test cases. So I will just explain to y'all my thought process throughout that. But again, I didn't solve the question fully, which kind of sucks, but I mean, it helps me know that where my weaknesses are, and we can just like move on from there. But to begin with, all right, let's get it. So to recap what this question is again, you're essentially just adding these two numbers up and then outputting it into a linked list. And so my original thought process was to first take each number from each linked list and add it into a string so that I can so that you can add them together. Technically I could have done this like in a more condensed way, like immediately put this into an int, but I didn't, so that's fine. So I added the first list, like this list for example, into a string of just those numbers. The second loop is taking the second list and putting it into a string. So then this section right here does the addition essentially. And so I'm taking these two strings using story, which is just string to int, and mathematically adding them together, which is what this answer is. So now the answer is currently this answer right now. And then this was the part that was the most difficult for me, was getting it back into the linked list. So my original thought process was just, to just like substring or do like string at I, and just like everything that I was doing was just like not working. So I proceeded to do mod. So when you do mod of this number, the first number that you get is 7. And then if you would do mod of 780, you would get 0. Do mod of 78, you get 8, and mod of 7 would be 7 with mod 10. All of this is with mod 10. And so the way that I did it was, the first thing I did was create two pointers, a head pointer to show what the beginning of the linked list is, and a pointer to help me add new nodes and keep track of where I am. And so this first while loop is just going from the beginning of the answer string to the end, which would be this answer string, so just 4. This first X number is taking the story of the answer mod 10. So the first time you do it, it's this whole answer string, and mod 10 of it would just return 7. So the first time you do this, X is 7, and then I set the new node that I just created, that value, to 7. And then this is where it was important, because I was going backwards, because you have to go this way to do mod 10. I was keeping track of where the head was, so I set the head to the new node because the head was going backwards, essentially. Like the first time you do it, 7 is the only thing in there, so that's the head. But the second time you do it, you want the head to be 0 instead of 7. So that was something that took me kind of a long time to figure out, because I haven't used pointers in a very long time. But I set the value of X of that node to the value that we just calculated with module. Then I set the head pointer to that new node. And then the next thing I did was to truncate the substring array, so that instead of calculating with these 4 numbers, now the second time I go through that loop, you're calculating with these 3 numbers. So that's what this substring is doing. The first time is just substring from this to this, then this to this, this to this, and then just 7. Because I'm going from I equals the length of the array minus 1 down to 0. So that is how I'm going smaller and smaller. And then this statement right here is to keep track of like the head pointer, because I was getting a lot of memory issues and memory errors, and I realized that like if there's only one thing in there, I can't really be moving the head like that. And so what it is if I is not equal to answer dot length minus 1, which is the first time that this goes through the loop. The first time this goes through the loop, this shouldn't happen, and else it should happen. So if it's the first time, we're going to skip this, and then we just set that the pointer array equal to the node and the head equal to the node. So now everything is pointing to this first node. Now the second time you go through the loop, you get the number, you mod 10 it, so now we have 0, and we set the value of that node to 0, and we set the head to the node. So now the head is at 0 and P is still at 7. And so because of this array, because it's not the first time, we now need to remember to make the head pointing back to P to keep track and keep everything linked. So that is what this does. Because we changed the head from 7 to 0, we are now setting the head's next value down to 7, so here, and then we're setting this node's next to P. And now the node's next, which is this new number we just set, is now pointing also to P, to 7. This is essentially to make sure that both of them are pointing to the end number, and when we get more numbers, you'll see that the head is not also doing this, but essentially all of this is pointing to the next number. So then after you go through this if statement, P is now set to the new node, which is 7, and the head is also set to that new node. Oh, I did that twice. It doesn't need to be in here twice, but you know, now we know it doesn't need to be there twice. So the third time you go through the array, all right, and you also truncated it, remember that. Third time, the third number you get is 8. So you set the value to 8, you set the head to this node, then because it's not the first time, you need to set the head's next number to the node, which is this number, set the node's next to P, which was this, and because this is linked to this, they all stay there. And so that's essentially how it works. And because the longer that you do it, you're just like using P to set the P's value into the previous one that was just entered, and you're moving head with the node that you just inserted. And so yeah, it works. It works for like 2 test cases, but it doesn't work for a huge test case, because if something was stoy and it being out of range, couldn't tell you. It just looks like this number is just like huge, and I guess stoy doesn't want to do that. I don't really know how to fix that, but also I've been working on this problem for almost 3 hours now, so we're just like kind of done with it. But it was a really good problem to like think through and like refresh my memory about linked lists, because I just realized that I'm just like really behind on that. So that was just like really informative and helpful for me, at least. So thank you so much for watching this video. I really hope that you found some value within it, and it kind of sucks that I didn't answer this medium leveled question fully. I couldn't be able to submit it because my runtime was too long, but I still think that like my thought process throughout this question is still helpful for anyone that is trying to answer this question. I hope. And I hope that like this easy question was still helpful for you as well, and hope that you were able to solve this one. And if you're able to solve this question and actually submit it, please let me know in the comments how to solve it. I would love to see it. It doesn't really matter the language, because the logic is always the same for the most part. But I kind of overthought this question to the extent, which is why I kind of think it took me so long. But it was still fun. I still enjoyed it. And thank you so much. Also, quick shout out to the people, because I actually streamed this entire thing. So if you'd like to follow me on Twitch, you can do that at twitch.tv/Daviel_. And shout out to He Average, Herdine, and Diamond, because they're hanging out with me while I was doing this whole thing. So thank you so much. So yeah, thank you so much for watching the video. I really, really appreciate it. And I hope you have a beautiful and blessed day.